Hello everyone, welcome back to another video on the TopSpin software tutorial. In the previous video, I introduced to you a new type of NMR, the 2D COSY NMR, and we also learned how to fully process the 1D proton NMR spectra onto each axis of the 2D COSY plot. Today in this video, I'm going to show you how to use the COSY spectrum to confirm our peak assignment for various sections of our compound. And in this video specifically, we are going to confirm the peak assignment for the N-butyl section of my compound. So in order to do that, first I'm going to copy the compound structure with labels from the previous document. And once I've copied that, I'm going to paste it into a blank area close to the bottom left of my spectra. Now I'm going to copy all of this into a blank PowerPoint slide. As mentioned in the previous video, the cross peaks or off-diagonal signals are the most important signals we are looking for because they tell us the coupling between close protons such as neighboring protons and diastereotopic protons. The diagonal signals, however, indicate self-correlation. They don't tell us much about structural connectivity, but they are used to assist the signal assignment. Now, let's take a look at the N-butyl section labeled with the letters F, G, H, and I. We did the peak assignments previously based on our best estimation, but now we can use the COSY NMR to confirm our assignment. First, you will need an entry point, which is the proton signal you know for sure. And in most cases, the entry points are the signals on the left side of the spectra. In this coupling system, since we are looking only at the N-butyl section, the most obvious proton is proton F, which has a chemical shift of around 2.2 parts per million. The example we chose here, F signal accidentally overlaps with the proton D signal, but you can easily tell them apart since D is a much taller and sharper signal of 3 protons, and because it is an isolated methyl group with no neighboring protons, so there are no splits in the signal. Now, after you identify the entry point, you are going to draw triangles to find the cross peaks. By that, I mean first, from the diagonal signal F, draw a vertical line going up and stop at the cross peak. Then, draw a horizontal line going to the right and stop at the diagonal signal, which should be here at around 1.6 parts per million. Since F is coupled with G, the signal at 1.6 parts per million is proton G. This way, we can identify the neighboring protons. Next, from proton G, you repeat the same process and you will find that G has a cross peak with the signal at 1.2 parts per million. This 1.2 parts per million signal is H. And so on, you can keep repeating the process, and by doing so, you can identify the signal at 0.8 parts per million, which should be proton I. By repeating this process, the main goal here is to confirm which signal at different parts per million is for which proton, whether it be G, H, or I. So congratulations! You just did your first COSY analysis. To recap the basic idea here, when using a COSY NMR, use a distinctive signal as an entry point, and in this case we used F as the entry point. And using that entry point, fish out its neighbors, and then its neighbor's neighbors, and then its neighbor's neighbor's neighbor, and so on. Thank you so much for watching this video. In the next video, I will explain how to use the COSY NMR to identify diastereotopic protons.